Okay, it's going. I think it's going. All right, R2, sets and real numbers. Here we go. They've got some terminology and such going on here, and let's look at this guy right here. 1, 2, 3, 4. You see that? That is a set of numbers. So it says, like, basically those are in roster notation. It's just listing the 4 elements that are in that set. Usually they will define a set with a letter. So let's say set A is the numbers 1, 2, 3, 4. Those are the numbers that are contained in the set. Like the person A owns the numbers 1, 2, 3, 4, that type of thing, okay? Now, to show that 4 is an element of the set, they use this symbol, 4E, which stands for element. It's kind of like a C, but then another little line. That's how I write it, okay? 4 is an element of the set 1, 2, 3, 4. They're just saying 4 lives in there, okay? And that's how they work. If we're talking about a number that is not an element, we just put a line through it, kind of like the not equal sign. So 5 is not an element of 1, 2, 3, 4. 5 is not an element of this set, okay? That's the notation that they will use, okay? They said it's customary to say name a set with capital letters. I just said that. They're calling it S. I called it A, whatever. And they said that you can do this another way. Let's say we have a set that's 3, 4, 5, 6, right? What you could do, if you want to be fancy, you could say this is in what's called set. Write this down. This is in set builder notation.
I hate that.
Okay, and this one that we just got done talking about, what notation is this in? I am. What notation is this guy in? 3, 4, 5, 6. I said it just a moment ago. Do you remember?
Standard.
Nope. It's listing them out. Listicle. It is in roster notation, like a roster. Roster notation, okay? But both of those are saying the same thing. Roster notation is listed out. If you have not very many elements, I prefer that one, right? Like 3, 4, 5, 6 is a lot more pleasing to the eye than this set builder notation, but this is what set builder notation says, okay? This is all the x's, or the set of all elements x, and then this line right here means such that. X is a natural number. Natural numbers are the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between 2 and 7. Okay? Not including 2 and 7. So that's why we say between 2 and 7. The numbers between 2 and 7 that are natural numbers or counting numbers are 3, 4, 5, 6. Okay? Both of those are saying the same thing. In this case, the roster notation is better. But let's say I had 3 listed out through 43, every element. In that case, roster notation is probably not the route we want to go. I would probably say this one going between 2 and 40, what did I say? 44, right? That would be easier to list out this way, right? Rather than listing them all out. So it just kind of depends on how many elements you have in your set. It might be easier to do one versus the other. Okay, all right, now we're talking about finite sets versus infinite sets. If you had to take a guess, what could you say about finite?
Never ends.
Infinite never ends. Finite has an ending. Finite is going to have just an exact number of elements. And then it says determine whether 10 is an element of the set.
Yes.
Okay, so A, is that finite or infinite?
Finite.
Even though it has the dot, dot, dot in the middle?
Yeah.
Yeah, it has a beginning and it has an end, basically is what I look for. So this is finite. Is 10 an element?
Yes.
Yes. I'm going to say finite. Yes, 10. I'm going to say 10 is an element. Okay. B.
No.
Finite or infinite?
Infinite.
Infinite. Is 10 an element?
I'd say no.
These numbers are getting
Smaller.
so they're not going to touch 10. 10 is not an element. No. Okay, good. Does that make sense? What would be the next number there? Do you know?
Probably something. Like 128.
Yep, 128. We're multiplying by 4. So 1/4, if I take that times 4, I have 1/16. A fourth of that is 1/64. Multiplied by another 4 on the bottom is 128. Yep. Okay, x such that x is a fraction that is between 1 and 2.
Well, there's an end, but there's a lot of fractions.
So is it finite or is it infinite?
It's finite because it has a beginning and ending.
Kind of.
But technically, there's an infinite number.
There's
of
an
fractions.
infinite number of fractions between 1 and 2, right? Because I could have 1 and 1/2. I could have 1 and 1/3. I could have 1 and 1/4. I could have 1 and 1/5, right? 1 and 1/6. 1 and 117th, right? That's a number in between 1 and 2, right?
Okay,
And I
so
could
it's
keep going on forever.
infinite.
So this is going to be infinite. So maybe I should not say beginning and end because you could still have an infinite. Infinite.
No.
10 element?
No.
No, 10 is not an element.
This is.
Okay?
finite, yes.
All right. X is a natural number. What are the natural numbers again?
1, 2, 3, 4, 5, 6, 7.
Like just the counting numbers, 1, 2, 3, 4, 5, 6, 7. So X is a natural number between 9 and 10. Finite?
10.
Yes, 10 is an element. How many elements are in this set?
8, 9,
Oh.
and 10. 3.
No. Natural number between 9 and 11.
Oh.
Yeah.
10 is the only number in that set, right? Because between 9 and 11 would have to just be 10, right? Okay, very good. All right, next. Use set notation and list all the elements of each set. Use roster notation. They called it set notation for some reason. I don't know why, because that's just this book. Roster notation. A says X such that X is a natural number less than 5. Wait a second. I don't have a beginning and an end. Isn't this an infinite set?
Well, we can just write some little dots. Well, it's a natural number doesn't include their integers? Or yes?
Yeah, integers are positives and negatives. Natural numbers
Are not negative.
don't include negatives. So they're giving us less than 5, so they give us the upper limit, but by saying it's a natural number, we know we can't go below 1, right? So natural numbers less than 5. So we're going to say, here's my set.
2.
Say it on there that we have like a lower bound because it's a natural number. It can't go below 1. So, okay, X is a natural number greater than 7 and less than 14. All right, greater than 7, less than 14. What do we start with?
11, 12.
8, 9, 10, 11, 12, 13, 14 included? No, they will say less than or equal to if they want that. But there is that. Good? Okay, now they're going to talk about subsets. Okay, so we had this notation right here. What does this thing mean? What does this little e mean? Element. So they're saying like 10 is an element of that set, right? Okay. Now we have this thing going on. It looks like a little C and a line underneath it. And that means subset. Okay? So for example, if I have like here, they give you an A and a B. A is this guy 2, 5, 9. B is this guy 2, 3, 5, 6, 9, and 10. Okay? A is a subset of B because everything that's in A also lives in B. All right, now, a subset of A. No, because B is bigger than A, right? So that doesn't fit in there, but it goes the other way. This is true, this is not. Like B is not a subset of A. Got it? Okay, all right, subsets. So now they're going to give us 3 sets. And I think when they do this, they say U is like the universal set. Like the set of all of the things. But I don't know that it really matters. Whatever. Then they have A is a set, B is a set, C is a set, D is a set. Determine whether it's true or false. Okay. Is D a subset of B? So D is here. Does that go into B?
Yeah.
All of the stuff in B is also in B? True. Okay. B is a subset of D. Does B go into D? No. False. Because B has more elements than D, so that's not true. Okay, C is not a subset of A. C does not go into A.
False.
False. C does go into A. C is a subset of A, so that would be false. And then U is equal to A.
No.
No, because it's missing 13, so false. U is not the same thing as A. This was pretty easy, right?
Club.
Yeah, pretty close. Pretty close, pretty close, pretty close. Okay, all right. Let's talk about complement. We've done complement before when we deal with probability, do you remember what complement means? Like in probability, here's what it looked like. No, you don't have to write this down. Let's say I have 4 red, 6 green, 5 yellow marbles in a bowl, right? I want to know the probability that if I pull a marble out, it is not yellow. That's the complement, right? Okay, the probability that it is going to be yellow is 5 out of, how many is that? What? 15? 5 out of 15? So not yellow would be 10 out of 15, right? These two complement each other because this one is yes yellow and this one is no yellow. Okay, that's a complement, all right? So here they'll mark it with a prime. So this, if A, let's say U, I'm gonna make this really easy. U is 1, 2, 3, 4, 5. And U is like the universal set, right? A is 2 and 4. What would A prime be?
Probably 1 and 3 and 5.
Probably 1 and 3 and 5, because these two would complement each other and add up to be the whole universal set. Does that make sense? It's just like the opposite, basically. The one that complements, these two complement each other because they make up the whole set. Okay?
Can you give me a second?
Sure.
To write that down?
Sure. If you would like to. Okay, we have 2 subsets and we have our universal set. So our universal set is this big guy, right? That's what we're referring everything back to. A is this guy, B is this guy. Those are 2 like smaller sets, okay? All right, what's the complement of A? A prime equals?
2.
Okay, I just look at the elements like A has 1. A does not have 2, so A complement would have to have 2.
4.
3 is there, 4 is not there, and 6 is not there. Yep, that's the one. Okay, is this too difficult? B, I'm going to put him down here. B prime is 1 and 2 and 3, 4, 5 is not there, and 7 is not there. Yeah? Okay, C is kind of funky weird.
Wait, hold on.
There's nothing.
Wait, what does that mean?
So this guy is the empty set, right? Have we talked about the empty set yet, or was that in trig? Okay, so this guy, this circle with a line through it, is the empty set. Let's write that over here. Circle with a line through it is the empty set, which means this. Okay, he has nothing in there, right? He is the empty set. He has no elements. Okay, and we'll talk about why that's relevant here later on. But the empty set, he has no elements. So what would be the complement of the empty set? All of them that are U, everything that's in U. So the empty set complement is like basically all of U, which is 1, 2, 3, 4, 5, 6, and 7.
So would the next one, the answer be an empty set?
So the complement of U then is the empty set. So you can write it like that, or you can write it like that. Either one. Empty set or that stuff. Okay, good. Not so bad. Not so bad. Not so bad. You think we should stop there? 10:02. Okay, how about we'll stop there. That'll be fine. But I'll give you a homework assignment so you can start working on some of those first ones. Okay, good? Yeah. All right. Goodbye, Aiden.